Hello students, my name is Rahul Paul and today we are going to discuss about variable separable method to find solution of ordinary differential equation of first order first degree. Okay, so let us understand what is meant by this method. So variable separable process to find out the solution of the ordinary differential equation. So first of all, let us understand its working principle, how it works. So our differential equation is in the form of mx dx plus ny dy equal to 0. This is the form in which the differential equation will be represented, for which we are going to apply variable separable method. Now, in that case, what would be the solution? So, to find solution, what we need to do? We need to integrate mx dx, then integrate ny dy, and the integration of constant will give you c. So this will be the final solution, where c is an arbitrary constant. Okay, c will be an arbitrary constant. So this is the working rule of the variable separable method. Now we will take examples to get the idea how to solve problems where variable separable method will be used. So let us get started with the first question. So the first question is, y times 1 plus x square to the power of half dy plus x times root over 1 plus y square dx equal to 0. So this is the question. So first of all, in this question, our target will be to separate the variables related to x on one side and the variables related to y on the other side. So what we are going to do, let us first of all take this particular portion on the other side. So we can write solution y times of 1 plus x square half dy equal to negative of x times of square root 1 plus y square dx. Now we will try to separate the variables. So we can write or y over square root of 1 plus y square dy equal to negative of x over square root of 1 plus x square dx. Okay, so this will be the criteria. Now we will integrate both sides. Now we will do integration. Now before integration we will introduce half and we will introduce 2y. 1 plus y square dy. And on the other side again we will introduce half integration 2x square root of 1 plus x square dx. So now we will consider y square is equal to, so let us not only consider y square but let us consider 1 plus y square equal to z square. So 1 plus y square equal to z square. So here we will write 2y dy equal to 2z dz. Similarly, let us consider 1 plus x square equal to k square. So here I will write 2x dx equal to 2k dk. So now we are writing here half integration. So this one is now z square. So square root of z square is z. And 2y dy is now 2z dz. And this is equal to negative of half. The same thing happens here. 2x dx is now 2k dk. And 1 plus x square is k square, so that's just k. So now we will be now proceeding. Oh, one more thing. Whenever you are doing the integration, please introduce plus c at the end. So there will be plus c at the end. Okay, so now I'll remove the first portion. So here, what are we getting? Or, so the z will be cancelled and the k will be cancelled. So it is going to be just the 2 and the 2 will also be cancelled, by the way. So it is just going to be integration of dz equal to negative of integration of dk plus c, or integration of dz is z equal to negative k plus c, or what we can get from here, z plus k equal to c. Now what was z? Z was square root of, z square was 1 plus x square. So z was square root of 1 plus x square. Similarly, k square was 1 plus y square. So k is square root of 1 plus y square. So now I will replace their values. Square root of 1 plus x square plus square root of 1 plus y square is equal to c. This is the answer of this problem. Okay, so this is how we do the differential equation. This is the answer of the problem. Okay, so next question we will do. Solve 4x plus y whole square dx by dy equal to 1. 4x plus y whole square dx by dy equals to 1. So first of all, we can write this solution dy over dx is equal to 4x plus y whole square. What we have done? We have taken this to the other side. So it has reciprocated. So now we will be taking 4x plus y equal to t. So if 4x plus y equal to t, so we can write 4 times of dx by dx plus dy by dx equal to dt by dx, or 4 plus dy by dx equal to dt by dx, or dy by dx equal to dt by dx minus 4. This is the relation that I am going to apply. So we can write dt by dx minus 4 is equal to t square, because 4x plus y is equal to t, so that will be t square. So next, dt by dx equal to t square plus 4. Now we will change the sides. Dt over t square plus 4 will be equal to dx. So this is the structure from where we are going to apply variable separable process. So we'll take one more step and do the integration of dt by t square plus 2 square, we can write like this, and integration dx plus c. So now we are going to do this problem. So what we are going to do here, so now this integration dt by this one, so we can write this integration is 1 by a tan inverse x by a. Like normally when we do integration of dx by x square plus a square, the answer is 1 by a tan inverse x by a plus c. This is the answer which we are going to apply now. This we are going to apply here. So here a is 2, so it is going to be 1 by a, that is 1 by 2, tan inverse x here is t by 2, and integration of dx is x plus c. Now we have to remember that t was actually 4x plus y that we had substituted early. So we are going to apply that. So we will be doing 1 over 2 tan inverse 4x plus y over 2, which is equal to x plus c. So this is the final part and this is the solution of this differential equation. Okay, if you want you can also write it in this process: half tan inverse 4x plus y by 2 minus x equal to c. That also is possible. You can take this as a solution or this as a solution. Okay, so we have solved 2 questions in this particular process. 2 more questions we are going to solve on our next video related to variable separable method, and then we will get to the new method. So that's it for this particular video.